to another video on Advent of Code. So we're looking at day 19, and how we got was it's just printing. It's basically just parsing the input and printing that. So what we had to do was basically we had a series of blueprints on how to make different robot types, and we have to work out the maximum number of geodes we can get from this scenario in 24 minutes, I think. Which I think part 2 will probably just increase the 24 to like 100 or something. And when we get the best numbers, we multiply it by the blueprint number. So these 1 and 2, and then add those two numbers together, and that's the answer. So what I think I want to do, I've done some working outside of the video stream, but the code there is pretty average, so I have kept this as is. So yeah, I am thinking I might actually, well, I found with the A star was, because we're searching for the maximum, not the minimum, it gets a bit tricky, and you have to have a good heuristic, and I found that it was kind of easier just to not do A star to start with. Gosh, that was not the right number, not the right key. So what I think I want to do is actually do something like this, and so you have a node that you're kind of starting from, and you would just have something like for in node.neighbors, and maybe you would also have guard here, node dot we want not node dot is complete. I might move that mouse there, otherwise we can return 0 u64. So no, we can return node dot geodes, yeah, like that. Otherwise what we can do is we can have a ret equals EU64 like that, I guess. Oh yeah, this one was an interesting one because I want to basically do a max, and yeah, I think I'll do the error. So we want max from our helpers, and here we will go something like this: ret equals max of ret and solve of nodes being in. So it's just going to recurse this function, and every time just get the latest ret. So we can kind of get rid of the A star. Might keep A star because it might become useful later. But yeah, this does the trick, and so this neighbors function will probably make better, because at the moment it's got quite a high branching factor to get to all the things, and there's some steps that can speed it up. So if we do this, we can't compile this because Max doesn't know how to do things. Yeah, so Max is wanting U64. So what I did to do that, which didn't actually work, was if we say do this and change these U sizes to U64 and U64 and U64, and so if we compile that same thing, it gets past that jakt stage, but then here we get a error where we're redefining defining max, and I think it's because in the C++ line, size T and U64 is the same type, whereas in jakt they are different types. So what I did to get around this, which a bit ugly, but we do as bang use size, and here we as bang use size and as bang use 64. So we kind of just massage the types to go through that same thing, and because they're the same type in the C++ land, they should be the same. And what's happening here is we now running through all those neighbors, and we're doing this print line thing here. So this is quite a naive solution, but in my experimentation it was actually better because it was just quicker. So what we can do is maybe do some prints on what we are trying to solve, and so we want to do that. We want to compile it and then run it. Boom, boom, boom. Right, and then just run it manually. And so here we can get kind of what our current is, and you see here we're like stepping up minute by minute. So I think the first change I'll do with my neighbors function. So we're doing this like can by, which is basically going through and working out all the things that we can buy with our current resources. What I think I want to do is our neighbors will go through and it will actually go for robots in blueprint dot. Yeah, I think I will be a bit lazy and have something like that. Actually, no, we can public function robots. It will take this and it will return a set of strings, and it will just be cost.keys. I think that will do the trick. Day 19. Yeah. Right. So I think I'm missing something down here. Blueprint.robots. We'll do that. Might complain about empty thing. We do throw, don't we? Oh no, we should throw in this thing. Throws. So haven't actually made any change, but that looks like it is compiling, which is what I wanted. So I think what I want to do is more for every robot we get, for every robot that we could build in the blueprint, we try and build that robot. So I think for this, and I think we're not going to have that. So that sort of stuff is going to be inside of this, except it's not going to push the then just yet. But maybe if rep dot is empty, we could do this, add path to end. Right, so when we when we want to do a robot, we want to see whether we can have it. So maybe we can have resources spelt right, and we might also have a new has robot equal true. Maybe we'll call that robots just to make it consistent. So here we want to basically, I might change this can by to be, better. So if not dot blueprint dot can by, and we're going to try by our robot with resources being no resources. So we can actually not do that there, and we could probably just check it off this dot resources. So what I want to do is that can by is change it to instead take robot, and that can be a string, and we have our resources, and we just return a boolean of whether we can buy that thing or not. And here we can mute red equals, we'll assume that we can get it, and here we can we'll have something like that in dot cost dot cost robot, and I think if we're going to do that, probably want a guard robot in dot cost. No, what do we want? We want dot cost dot contains robot. Yeah, that's what we want. Otherwise, we can return false. We can't build it because that robot doesn't have a cost associated. And here we can basically check. So if not resources dot contains so if our current resources doesn't contain one of the costs in robots, or resources of that robot is less than what we require to do it, then this means ret will be false, and we can break and do that. And you might notice that this is kind of similar to this one. We do that check, but there we also did that. We were returning a different structure, whereas now we're kind of just returning a boolean. We can't buy that. So now this whole thing is just irrelevant now, but we'll keep it in because it kind of shows how we do the buying of a thing. So if we can't buy, we has resources equals false, and we want to check whether we have, I think I kind of want to see whether if we have the resources and the robot. So I think because basically if we don't have the robot, maybe we can have another one can build this. Wow. could return like true things. Because if we don't have the resources, we want to make sure that we have the robot to be able to buy it. I guess what we could do is no. Yeah, so if we don't have the resources, if not has resources, we want to. I kind of just want to do it this way, and maybe get rid of this. Maybe get rid of that in a way that we copy paste it. And here we do this instead. Blueprint, and that's like dot blueprint, so we make sure that that is, otherwise we it just can continue. So like there's no possible way we can buy it. That ret is, we can do something like that, yeah. Right, so here we have our things, dot blueprint, so that's the same kind of check, and here we can go has resources equals false, and here I think if not, so that resources and this resources means that if not robots.contains has robot should be false, and we should break there. And I think in this case we actually just want to continue, because we always want to check whether we have a robot. Like we might not have a resource of one thing, but we have a robot of that. But the next thing we don't have a resource of, we don't have a robot. And so here we would guard that we have a robot. Otherwise we would continue, because there's no possible way, if we don't have a robot, there's no possible way we would have got the resources, and there's also no possible way to earn the resources from that. Yeah, like we just need a robot to be able to buy that. Right, so here, and if we don't have the resources, what we want to do is basically go through it enough. Yeah, so we want to like collect what we have. I think, yeah, we want it to be in that sort of order. Right, so we clone it, and then basically while not has resources, while we don't have the resources, we will assume that we have the resources again, and then we will collect some stuff, and then we will do this check again, but without the robots part. Maybe we can do it like that. And I think this if could probably be a while. So basically, while we don't have the resources, we will ensure that we have the resources. And here we probably need to skip out that and maybe get rid of that one. And here we would also check on our node resources. And and here we can probably just break because we do want to get out every time. And at this point here, we would have bought the resources, and so we want to buy that robot. And so I guess the benefit of this one over this last way to do it was this way only stepped up 1 day at a time. This one will step up as many days as it is to get that particular robot. So every neighbor will basically have up to 4 branching factors. It would so like on day 1 it would try and buy an ore robot, or it would try and buy a clay robot in Obsidian or Geode if it can. So in this instance it could possibly buy an ore or clay because we start with 1 ore robot, but it would go to day 3, I guess, 3 and 5, so it has enough ore cost to buy that robot, and it wouldn't bother buying these other ones. But then the next day, if it had that clay robot, it could then buy an obsidian robot, and it would wait until it had 14 days, so it'd skip ahead 14 days. Right, so that is that, and yeah, we also need to add the robot after we collect it. Right, so that is basically better than that. And there's this case here. I'll see if this compiles and kind of runs. It does not. Right, that's, I saw something that might do it. Yeah, the cost we don't get. So that will be blueprint dot costs of robots, and maybe we can even get it from the actual node. Like, it shouldn't change, but it's probably best to be legit. Right, so here's where we get. Do we not have contains source jakt? And what are we on? We're like in a dictionary. That one. Dictionary contains. Yeah, contains a key. It's because robot wasn't found. Maybe if we do that. Yeah, that was better. Has robot is right, so has robots is bad and has robots. Right, that looks better. That looks better. Compiling up, and so that actually did better. Like, it crashes, I guess. But here we can see, right, so our first one was minute 0 we have 1 robot, then we have 2 ore robots at minute 5, and here we have 3 ore robots at minute 8. So we kind of go up, and we will complete quicker. And I guess in the solve function, I might also want to do if node dot is complete, we can print line returning that node dot geodes, and that is what we want. And no, well, actually that it does a reasonably quick job of crashing after a second, so I can probably do this to compile as well, and it will kind of run it. Yeah, so here it should get to the 24 and it will return something there, and then here it bought a clay after getting like 1 million oil things, and there's like another thing here, and so here like we got an obsidian. The minutes 38 does not seem good, so I guess in our neighbors, when we are doing this collection, if node dot is complete, we will probably want to break that, and here we can probably do a guard on not node dot is complete, otherwise we continue, and here we can probably well, we don't have resources, and not node dot is complete, just because it saves that line there, I guess. Alright, so this way we should not get that like overflow. Yeah, like obsidian we have like a ridiculous amount, and that's probably why we're getting that seek fault. Well, maybe. Yeah, like we're not getting a seek fault now. We're just running forever. So here we get to 24, we return 0, 24, return 0, 23, and we have very high ore resources. No, resources is fine. Yeah, we shouldn't get more robots than there are days. But we also really shouldn't build more robots than unnecessary. So this works better than it was. So if, say, we comment out that and just do this, we should see just all the end cases, the leaves of the search, I guess. But we're doing basically a complete traversal of the graph. Yeah, so we do a lot of returning of 0. So what we can do is try and get rid of some of those irrelevant nodes. So there are instances that we don't want to buy things. So for example, say if we had 5 ore robots, every time we have a day we would generate 5 more ore resource, but the robot that uses the most ore only uses 4, and we can only build 1 robot a day. So really we should only have at max 4 ore robots. And there's no point in building more after that. So I think that's a good check to do. So we could probably do that check before we kind of do everything. Maybe we could do that guard first though. Right, so here we want to check all the possible costs. Now, yeah, I think I did this as like a kind of function on the max cost. But our cost is just our cost is just public, so we probably could just do it in here. So we would max yeah, we could call it max robots, I guess. And it can be 0u64, not 8. 8 is too high. And here we can probably just go for what do we call it? Num in dot blue. No, we kind of want to do in cost, I guess, in dot blueprint dot cost, and just do it over that base dictionary. And here we can then go like for R2 and num, I guess, in cost. And if R2 is the same as what we're trying to build, then we will continue. Is that right? It's what I have in my. I'm kind of looking at the other code I did, but that doesn't seem quite right, because we may as well not. So yeah, like instead of doing that, we may as well just get cost of robot like that, and just get that. Yeah, and I think that's kind of what we want, because we're wanting to see the cost of robots. So this is going to be our so this is going to be our cost of robot. Yeah, but we'll just add bang that as usize, and we'll also do max robots as bang usize, and we'll cast that back to UC support there. And here, if we have robots dot get of robot, and maybe we can coalesce that like that, and if this is equal to max robots, then there's no point building more. Maybe we can do that as a guard, else continue. No point doing that. So we can guard that we currently have less than the max, and if we don't, then we continue. And that way we should, and I think yeah, cool, that other print is good. That is loud. I've got a thing charging that decides to turn on every once in a while. I was too impatient. I kind of want to not run the test scripts anymore, because it does take a while. And I just want to run it in less until we get to the point where it is quick. Yeah, so here we just crash straight away on a pointer. Right, so we get that first one and we like just crash straight away. So that means that yeah, we probably want a guard cost contains robot, else we can continue to the next cost. Gosh, I didn't want to click that. I did not click that. Yep, cool. No, I don't want to save. Didn't want it to open. doing it? Yeah, we are. Right, so now it shouldn't crash straight away. And here we can see, yeah, so we get 4 ore robots, but we never get that 5th one, so we actually kind of skip it. And here our first ending point is actually when we have some obsidian. So that's kind of looking hopeful to not kind of get too many things. But you'll see here we do get quite a lot of clay, and so I guess, yeah, this one here where we have 29 clay and 9 clay robots, and so the clay we can get up to 14, so it is useful having more clay robots, but on minute 23 we don't need that 10th clay robot. So another thing I did to kind of lower the number of neighbours is like check whether we should bother building a clay robot, because say we want the max. If we want the max, we basically want to be building a geode robot every step of the way, and then that geode robot would then generate a new mine some geodes. So after a certain point we kind of so like a geode robot costs 7 obsidian. That basically means that we, for X number of minutes before that, we want to like not basically, yeah, not buy a thing. And so what I might do is just to have better things, I'll just quickly look at how I do it. Yeah, so I just do that. That's also another check that I should just quickly do is this max thing we only want to do if robot not equal to geode. Otherwise we would basically never build a geode. Yep. And I think the rest of this is what there. We don't do this one as well, but we might now that I did that check. But yeah, I also want this should make clay or minutes remaining, which is there. So this one I'll make a thing on the blueprint. Public function, let's go like that, should make clay or, and this will take this, and maybe it will take minutes remaining, and that's going to be a U64, and it's going to return a bool. Now this is kind of interesting because basically, say if we had 5 minutes remaining, on the first day we would buy a robot, so we'd have one robot and we'll be generating another thing. On the second day we will be generating, we'll buy another robot but we'll be generating another thing. On the next day we'll be generating one more. But kind of what this is this equation here, which that is kind of n times n minus 1 divided by 2, I think is what we are doing. But no, this is a different thing that we want, because we are wanting kind of the end result of this, which yeah, basically we have some x is going to be no, we have, like, the return is going to be oh no, yeah, we just want to return the end based on how many days left there are, I guess, based on the cost, which that will be like you'll have a quadratic formula, so you'll have like the a plus or minus square root of b minus 4ac divided by 2a, that sort of thing there, because we will have this will equal something. I can't recall what I did. Problem is we can't use square root in jakt. Had a look and couldn't work out how. So how I did it was basically noted that we I noted that we only had so many things in my example input and also my input, so we could basically have this. We'll call this min remaining, and here maybe I can do a fixed thing here. If we had a square root, this could be round of 1 plus square root of 1 plus 8 times cost divided by 2. But instead we're going to go if cost is greater than 10, minutes equals 6, and we're going to change that remaining to be minutes, and here we're just going to have that one, and that's going to be 5, and that's going to be 4, not in, and this is going to be 3, and this is going to be 2, and we're only going to have 2, and then this is going to be 6, 3 even, and 2, no, 1, and that is going to be 0. So it's basically reversing just for those things, and then here we can, whether we should be making it is really if minutes remaining is greater than minutes plus 2, and the plus 2 was for the cost to build, I think. But yeah, so now we have this should make clay or ore, and in here we can, if robot equals clay or robot equals ore, or we can if we can do a guard actually, guard dot blueprint dot should make clay ore, and I just want to copy that and then maybe search for should, yep, and then this can go like that and get rid of this thing here because it will cause issues, and here we just got do that, and if that is not the case, then I want to continue and not build that clay robot or robot. And so now if we compile that, we can't do that, can we? We need, no, it do we not have minutes remaining? I thought we did. We don't. Public function minutes remaining, and this is going to return a U64, and it can just be implemented by dot minutes. No, it can be 24 minus dot minutes, and here I guess minutes remaining equals 0. Yeah, I kind of want that hard-coded 24 only in one place, because it is probably going to get used for the part 2. We needed this. Right, that looks better. And so now this is like, I'm looking to most of the checks I did on the host. We get a crash like straight away. We get a panic. Yeah, so we get a panic because we're adding path to end. So I guess in this case, in fact, we could probably panic. We could probably do something like format add path to end. Yeah, so actually no, we don't need to do that because we should have the information. So we're in this case here, and what this is saying is basically there's no path to the end from this point. And in fact, I think if we don't have a geode robot, there's no point actually going to the end. So that can be the first step we do. So if not dot robots dot contains geode, do some stuff which can just be a panic for now. Otherwise, we will just continue. So if we compile that again and run it again, we should probably see more output. One more to compile. It's like taking a bit to compile that last one. Try just running that again. Yeah, that did it. Did a weird L stat at the end. Right, if we have a robot, we want to add pass to the end. If we don't, we can just error and we won't get to the end on that. Yeah, so without that not, we should get a bit more. So here we iterated through like all of these, and we will see that it gets up to like 22, but there's nothing it can do here that it can improve, so it goes down. Does actually complete some things, so I probably bought like an obsidian at that point. And here we have a geode, so we kind of just want to sit and generate a thing because we would be able to return 1 there. So I think here we would just have a similar thing to this, mute node, and while not node dot is complete, node dot collect, and ret dot push node, and that's all good like that. Right, so that will basically step it forward to there. And potentially now this will actually run quick-ish. It's still printing out a lot of stuff, but yeah, it will potentially get us some stuff. Right, so it's doing a bunch more. It's printing some stuff and it's returning some things. So what I think I want to do is maybe even just do that and not print out anything and basically see if it gets a thing. Maybe here we can have a print line. Part 1 is now that result is that, and we can go part 1 and result, which after we get a thing, after this returns, we should get a thing. So we might actually get that first blueprint quite quickly. It was quicker to solve than the second blueprint in the example input. But yeah, so if we run this, hopefully it like prints out something. Otherwise, what I can do is kind of see it stepping up. Or yeah, so part 1 is now 9. So I got that first blueprint done pretty quick, and it should theoretically get 33. So that like wasn't super slow. If we run that again with time, and we'll see that we did indeed want to get 33. So theoretically, we can run this on our actual input, and we might get an answer. Yeah, so it took like 21 seconds. That doesn't seem right. Do we have like PWD? Where did I end up? Yeah, so can we just run a 19 on this bit, maybe with the batch building time? That didn't work. It did work, but it didn't like update it. Because yeah, 21 seconds doesn't seem right. Like it didn't seem like it took 20 seconds to get that output. Like maybe it did. Nah, that wasn't. Apparently around 20 seconds. Right, so it takes about 20 seconds for the example. What we can do is just run against the example and the output. It should fail because we are printing out this. So we could probably get rid of that, and maybe we can get rid of these. Gosh, Hack Studio is like not going. Is it just because there's can't multitask? Yeah, so it says fail, but it doesn't print out the part 1 answer. And for the actual input, we should also get a fail, but it will just say something else. Whatever it is. So it's like a bit slow. And like potentially like reordering some of these checks or like making it more efficient to like get the information out, because there's a bunch of for loops and stuff, but it's still reasonably quick. I think I want to run that kind of manually so we can see the output happening, and potentially like is that right? I kind of want to yeah, this is on my actual input. Yeah, I don't think I've run this on my host machine, I guess. Inputs day 19 dots input to input. Sorry, there's things off screen, I guess. And it took 3 minutes. Not that much there. 1981. I think that is the right output though. So what we can do is go to here and write 1981. Click in the right magic place. Maybe refresh, and then click in the right place. Yep, 1981. 1981, and if we submit that, it is the correct answer. Now, what have I done? Yeah, so I think I want to look at part 2 just to see what it is. Gosh, yeah, it's just 32 minutes. 32, but elephants ate most of the blueprints, so I only have 3. Which is probably good because we have like a few, like you saw this printed out a few, so we only want to do the top 3 for part 2, I guess. And that's just an example on how we do it. And we still want to get each of the one. So we just get the top 3 and just multiply them together. So we don't have to worry about the ID numbers at all. So yeah, what I think I will do is first add outputs day 19 output 1981 part 1 1981 and maybe get status maybe, yeah, get add just everything and get commit, and this can be day 19 part 1, and I think I will just push on ahead with part 2, so like this should just work. So part 2, yeah, we did have some stuff, so if I save that, yeah, the gutter goes. Part 2 will be similar. Part 2 equals 0, U64. Actually no, because we're multiplying, I want it to be 1. And here, I think if blueprint.getID is less than 3, we're going to do some stuff to part 2. So I think here our node can have a notion of time, which is U64, and we can probably pass it in here, U64, and maybe it can default to 24, and here we can just go dot time, and because I only did that 24 in one place, we only really have to edit it in that one place there and kind of pass it in, so it's part of the thing. We can't do too much while it's running that. I just want to make sure it's still good. Right, and here we also probably get another example output, so 62. So we can add that once, like now, I guess. Not inputs, outputs on day 19.example. I don't normally edit the examples in here, but my shell's busy running a slow process, I guess. Part 2, so that was 62. Oh, of course it just crashes. Right, so we got a pass and all of that. stole up some of the input, interestingly, but yeah, it did some things. Alright, let's open up Hack Studio again. I think I'll maybe nearly pushed the wrong button. What I can do is get diff, so that's adding in that stuff, and we do add the extra thing there. So if in this solve, what we can do is let node2, and this can be node construct, pass it the blueprint, and we can give time being 32, was it? 32 minutes, yeah. Yeah, I think I just want to get rid of that now. Maybe I can start up again, just because to get through all the windows, it's like Windows then number key, and that is now 5 and it was 4, and it's just easier for me there. Result2 equals solve node, and part2 times equal just result, and maybe we can go print line part2 equals is now that, and result equals that, and we can go part2 and result2, and we need to do 2 there. And maybe we can just go example, right, so it doesn't like something there. Maybe if we just run that by itself. I think I'm missing a go away. Oh my god, just go away. Just stop. I don't care anymore. Missing a quote there. That's alright. Yeah, so in our clone, I guess that was, we also need to go let time equal dot time and pass in that to here. That looks good. And here I might look at the A star again, depending on whether this is quick, I guess. So maybe we'll just run this, and hopefully we get an output, I guess. Like it might take a while. So this is the one that took, in fact, how long did it take? It took like a minute with that on my host system. Right, so I got that. I don't know if it's right or not, but yeah, because we need to get all 3. It did say 9 doesn't seem right. Yeah, 56 should be what it is, and 12. And we never actually print out the part 2 as well, so we could probably do that just after that. Print line part 2 can be just part 2. So, and it only got 2 things, so I think I want less than equal for that. And maybe just jakt that, and maybe if we pass in the second node. So yeah, it was just solving, yeah, so I think we need to say that that is a node. Right, so this should now maybe take a bit longer, but print out some different numbers. So, for example, 56 is what we want for the first one, and 56 in '62. It doesn't give me the actual example output. That 62 isn't the number I want. I didn't want that. I wanted that one. What I might do is go like that and copy the example input to that and then run that, and just to see how my host machine solution gets for part 2, because I guess it's not 62. Yeah, it'll be 56, then 62, and then whatever the third one is. And yeah, annoyingly it doesn't actually show me the answer that it should be. And so this isn't printing out a thing just yet. Now, on the code I did, like on my host machine, I actually used a star for the second part, but I changed the H functions because at the moment it doesn't really do much, I guess. And what else did I change in this? Yeah, I think I changed it all. But yeah, an interesting thing I saw with the A star for the first part, when I used it for the first part, is the first return result wasn't always the best, which alludes to your heuristic not being good. But I found like if I sampled the top 25, then it would be in the best. But the brute force approach that I just did was quicker. So I ended up just doing A star for that. And so to do that, we can really just go A star being that, and maybe have star. And I realise it doesn't actually need to be mutable. It needed to be mutable for a different reason before. Right, it didn't like saving that because we're running other things, and I've noticed since I've pulled the latest Serenity is my system monitor isn't really saying that I'm going full bore. In fact, like this day 19 is apparently using 0% CPU, but it's doing something, and my host machine it's spinning up. It's doing a thing. So I'm not too sure what's happening there. This is like because I had to rebuild the file system, so I wonder whether I copied something there that like broke it. So I think what I can tell from this is taking just too long. So that took like 193 seconds. So it's like a couple of minutes, and it still hadn't printed out the first output. But if we say do this, we should get some output quicker, I guess, because we're printing the current output as we go through the A star. Doesn't like that. Doesn't like A start because A start doesn't exist, but A star does. The parameter was a start to A star. But yeah, right. So we couldn't do that. That takes longer on my host system while I'm recording stuff. Yeah, so it took 4 minutes, and example day outputs day 19 dot example. This can be 3472 and 3472. I'm just not seeing it. Right, so that still didn't do it because it didn't like that. So I think I want to look at this, the code I have for this is like pretty gross. So here we need to guard results to dot has a value, else panic could not find a solution, and do a bang for that, because a star returns an option, like so. And yeah, it's interesting that that didn't get picked up in the jakt compiler. It was only in the actual compiling. Right, so now if we do this, this should like print out a bunch of stuff. Or like nothing? No, we should be printing out something at least. Oh, we need to do, so we needed to do the part 1 first. And here we got a result fairly quickly, but it was the wrong result. Because our H is not great. And so for our H, I think I just need to look at that, and so I do that, and that, And if we look at this, so reckons hex pseudo figured. So here we get our current bit. We should, so we return at that point, and we have a lot of clay, like a lot of clay. We don't need that much clay, I guess. But we return 0, which is not correct. So for the H, we currently do nothing. So what I'll do is, instead of doing nothing, I'll do something. So here we want to check whether we are already done. So not dot is complete. And if we are complete, we can just return 0u64. And here we can have some sort of return value, and we can just go for robot in dot blueprint dot robots. Did I call it? I had it somewhere here. Blueprint dot robots. And here we we want to check how many robots we actually have. Robots.get of robot, and we'll coalesce that into 0. We'll just do that maybe. And here we're going to have another function that I'll make, which will get us the cost as OR. So OR is like the cheapest option, and maybe we'll just pass in robot for that. and here we can do some kind of heuristic-y things. So here we're going to have OR of 1 times robots times time, and this is going to be the income generated by current robots we have for the rest of the time. And we're also going to do OR of 1 times time times time minus 1 divided by 2. And this is going to be the income generated by new robots built every day. So basically every day we build it, so it's going to be that same function, 1 plus 2, where's my plus, 3 plus 4 plus 5 plus 6, that is equal to 6 minus 6 times 5 divided by 2, I think. Basically n times n minus 1 divided by 2, which is what we're doing here with the time times time minus 1 divided by 2. And that will get us the, basically assuming we're building a new robot every day, we'll do that. Last of all, we'll do OR of 1 times time minus 1, and this is going to be the cost of building a robot every day, which is it costs 1 day to build the robot, and it doesn't have that cumulative effect, but we want to kind of capture that cost in our function, because like once we spend it, I'm kind of thinking in terms of the node's wealth, I guess. So it's basically, we're bringing it down in terms of cost of ore for everything, and your wealth is how many robots you have plus how much it costs to make the robots. Basically that's the value of the robot assets, and then you also have however many resources you have, which here we're simulating it by this, but in the we can return red. In the G function, we currently just return the geodes, but we can probably do a similar thing that we have at 0u64, and we do the same robot in blueprint.robots. And here we want to do like 2 things. Interesting, I'd do it like kind of twice here. So we can go ret plus equal to blueprint.cost is or, and this is going to be our robot, and we'll times this by resources dot get robot, and maybe this times can be like that, and we can convert that to 0, so it might be 0. In fact, like maybe, yeah, if dot resources dot contains robot, we can do that check. No, I kind of want to select the whole line and then do that, and then here we can just go resources and just get whatever the value of the robot is, and it should always exist. And we also want to check whether robots contains robot, and here we, yeah, I kind of wanted brace there, and here we can do ret plus equal to, this is going to be the cost of the ore, so I guess like we work that cost out twice. I guess yeah, it's getting done twice, but that's alright. And here we want to just robots times robot. I guess it's like not too expensive, so we can probably do the same thing there, and if it's just happens to be 0, and we're only doing it like 4 times, I guess, or of 1. Right, so now the important thing is to make this cost of ore function on our blueprint. Public function cost of ore, we're going to take this and we're going to take a robot, I guess, and as a string, and we're going to return a U64. So if well, we can probably do guard robot not equal to or, otherwise we can just return one U64. Yeah, and if it is not, we want to look up the cost of this. So we want to get cost of this robot, and maybe we will for num in that, and for everything in the cost that we have, we probably want a ret equals 0 64, and here we probably want to ret plus equal to dot cost as or of this inner robot and times it by num, and here we can just return ret, and I think that's it. And this will kind of recurse in all the time, and it will stop when it gets to or, and like all of the inputs only really have 2 things in the cost, but I'm not really hard coding that at all. Right, so here we just need to do some throwing on our G and H, so this will be throws, and we also needed time to be dot minuets remaining, and this probably also needs to throws because we get all the robots. We don't return from G. Right, where do we get here? Cost of ore, we don't get that. That R needs to have robot attached to it. Cost of ore. That's just in the function. Cost of ore, we want that to be robot is that. We don't have a ret 3, that's alright. That's 187, and that's cool. So that's back down here. Ret 3 we don't want, and this is now going to throws because G and H both throw. Right, so that kind of works now. So now if we run this, and we'll do it inside less again because we're going to get some output of like our current chain of things that we're doing, and that, yeah, we do the negative there. So I think this, if all goes to plan, this should just return the thing. So here we can see like it preferred getting clays for some reason, then we're back to ores, then we're like it. Yes, so I suppose like that's at minute 5 and that's at minute 5, and it kind of steps up by minutes, just trying different combinations, and we should start seeing, yeah, we're getting like obsidian now, and we should get, like it's a bit slower, but we should get maybe some output. So maybe what I'll do is not print out that and just print it without the less, and then see what outputs it's getting, and kind of how quick, I guess. Yeah, so run it without less, and we should get to these points, and hopefully it should get just the maximum number it can, and it might take a couple of minutes, but it might also not. And I think we're just on the example input. Yeah, so we get like 27 clay still, but like at minute 15, so like that clay could still go to buy heaps of things. Yeah, like if we have 27 clay, gosh, the mouse is slow, we could buy a bunch of obsidian robots. But yeah, I wonder whether this will get a thing. And like my host one did kind of get something, and it took like close to 5 minutes. Yeah, so my example actually took longer, like 5 minutes for the first for example input, but then for the real one it took like 3 minutes, and because I'm like recording a video, it will take like a bit longer as well. I just want to get some sort of output. But yeah, it is a bit slow, and like it should get to there. Did I change that? This and get my A star. Did this gonna get changed? We did that thing. No, I think that is very similar. Oh, we did that. Scene. That's just for debugging. Yeah, that looks all good. Well, I guess I want to make sure it's like that, and do that. Maybe I do want it to print out just how we do it. Design part 2 is now the result equals that, and part 2 and result 2 bang. And maybe recompile that, and from that, and that should give me an indication on whether I should be expecting an input. Right, 56, I think that might be right. Where did it start? day 2, part 2 start, not day 2, up there. Right, so 56, looking good, and like, it took a bit, but that's alright. And then 62 should be the next one it finds, at however long it does that. I realise because I'm also running on the host system, well, I've got multiple CPUs, so it's probably alright. But yeah, this just takes a bit of time, and I guess 3472. So that is the output I get in the thing in like about 5 minutes. So what I could do is maybe I'll just get rid of that one and we'll just do a test on 19, and that should run it for the example input. It'll take like about 5 minutes, and then I'll run it for the real output, which I'm assuming will get the same answer. And in the meantime, what I could do is just put in the answer that my host system got, 10962. Need a refresh, I guess, and scroll down again and click in the magic box there. 109. Maybe this needs to not be full screen, and refresh that. Click somewhere there. Yep, 109. Is that? Yeah, that is doing it. Yeah, I don't know. I do not know. Maybe if I like scroll down manually, right to the bottom. Yeah, that looks better. 10962. Yeah, that's better. 10962. So if we submit that, that is the right answer. So I believe that is what I will get if I just wait a little, and a 19.output. We can probably, because we know it's the right thing, and like maybe I will just stop that. And part 2 is 10962, and potentially that will mean, yep, XU just crashed. And then crash report a crash, because it's like, oh my god, you need to like let me like make a crash report. So I'll just let it finish, I guess. Takes up a bit of time. Like, I'm very impatient when it comes to this. Yeah, like, right, you've done it fully, and then this opened. Gosh, yeah, running things at the same time as other things, it's maybe a little unsafe. Yeah, cool, we'll close that. Right, so maybe we'll look and see what our diff looks like. If we're allowed, we might not be, yeah we are. So I added that cost of ore, added the time, so we can have different things, and did those H and G functions. And part 2 just shells out to the A star, and A star just change that mutable, and we don't comment, and we put in what we do. So I think I'll add everything and commit up that, and like just while it's running in the background it should finish, but it's just quite slow, and like what's the point of watching a video and just something going slow. Day 19 part 2. So if we do that, and maybe do a push. Yeah, so I've got like heaps of stuff on my event now. Wonder if this push will work. Might need to do a pull or a ch mod, but yeah, it's waiting on this. So it's quite slow, and I wonder whether speeding up would be a good idea. Not many more days left. Gosh, it doesn't want to push. Does not want to push. It wanted to push. Cool. So it did the push, and I'll do a pull because it will update the README at some point. So yeah, I suppose you haven't seen the code get the right answer, but it likely will. It is very similar to my current code. I guess we could see what the current code is, and then well, the current code, yeah, so if I get this guy, and we can like do a diff on day 19, see what this did. Right, so it passed the example input on 6 minutes, gosh. So if we do a diff on both of these, I like this diff actually. It's a clear colour, I guess. Yeah, so here we can see I made ID public for some reason. The max cost we did somewhere else. My fixing was slightly different. Max cost we just did inside of it. Cost of ore, we had a similar thing. I took out that can buy because we don't use it. Oh no, I changed it to do a better thing. I had this as excess, which I was using to see whether we had too many robots, but instead I'd just do the max cost, which did the better trick, so we just don't buy it if we do it. And here we must be in the neighbors, so I didn't have the blueprint.robots, I just did it by a string like that. And similar thing, yeah, we get the cost of that robot if it didn't contain it, but we just check that it is there like that, and we never actually just use cost as is, we always go off that. We had like this, that all looks pretty similar, that's just going through and checking that we did it. And interestingly, I only checked, because I think like straight after this was a break, I only check the robot if it doesn't have a resource, so like potentially like it doesn't, it can't, but like it still worked. And here we do similar there, and here this looks kind of similar. Yeah, though I guess we didn't do that initial if thing because like it's kind of just part of the while, so I didn't need to do that. And if that's all good, here was a bit more debuggy stuff. So that was like what I originally had. So it's got like comments out for everything. Then we buy it, so that's all pretty similar. The new code is a lot nicer. Here, yeah. So I don't think I had this check if we weren't a robot. This is all commented out, just old stuff. And here we're in our F and G. Yeah, so this I don't think I did somewhere. But yeah, our F and G are pretty similar. Slightly different naming, so like the diffs actually show. And that was commented out, so we didn't use it. That is like slightly different. Gosh, I don't know why. I like reordered it to make it look nicer. And here that always runs, but that's just commented. Yeah, so instead of just deleting the A star, I kind of commented out with a guard. Here is pretty similar, and here, like in the A star, I did like some debugging with how many things I'd seen, and then I also did this like sampling, which, as I mentioned, like the part 1 doesn't work with the A star, but part 2 for some reason does. Like, yeah, I guess the heuristic, it needs that kind of leeway of more minutes to like get a better like state to start searching off, so it gets a good state and can carry on. But yeah, finding a good heuristic is hard. Right, and so that's basically that. So there's no like real substantial change, and I was hoping in that time this might have finished and shown that it all kind of works, but it did not. So what I might do is actually just remove that date 19 from host. And like one change that, one thing that I could do, right, so that passed there, and it took around 5 minutes. One thing I was looking at was, so say this, I'll do it this way, build date 19, and go to here, and then go to profile thing. You can make a like profile of a application or anything running under Serenity, and like if you just leave this go for a bit, so maybe like, I don't know, 15 seconds. I can also do it over like the whole time, so if I, instead of running it like that, I just did profile before it. In fact, we can probably kill that, and you go profile and run that command, and it will do the same thing but over the length of the thing. And in here, the flame graph looks quite cool, because it kind of shows where a lot of your time is spent. And here we can see A star is actually pretty heavy there, and we do hashing. So hashing is actually quite an expensive, we don't have a hash studio open at the moment. Hashing was reasonably, can we like open up a thing? Yep, advent of code. If we open up a hack studio, just in the background. So hashing is reasonably expensive because we, like it's like some dead code there. it's interesting. The hashing is reasonably expensive because it uses format to basically format a string out of what we have and then hash it, which it shows up quite a lot in this flame graph, that's what we call it. And here we can see what happens in neighbors is we have like a cost on like cloning, and like our F and G are pretty similar. Yeah, so if we look at day 19, I added a profile file, that's kind of how it does it. Something weird is happening with the thing. Yeah, so hash does that format, which like potentially we could hash it differently or do something. But yeah, this is kind of a way that we could investigate why things are a bit slow and like determine where the kind of slow points are. And the F and G, well, really it's H and G. G looks like more costly than H. So G does like these two things, and like we could potentially do some checks, like this cost is or it doesn't actually show up in well, yeah, it shows up like there. The cost of ore like potentially doesn't need to be called if both resources and robots don't contain the robot that we have. And the cost of ore probably could be cached. That would probably make quite a difference. Is if it's already cached, then we can just return it straight away. So like there's things that you can do to speed things up, but I think for now it shows that it kind of runs in 5-ish minutes. It's kind of slow. I'm gonna kill this because I'm probably not gonna that's cool. Not gonna revisit it, I guess. But yeah, for now, that was day 19, advent of code, both parts. Hopefully you enjoyed the video, and until next time, see ya.